Hello everyone, we've got a tricky, I think, really tricky probability question here. Okay, so let's have a look at this one. So it says, in an after-school club, students can choose to take part in art, music, both or neither. There are 45 students that attend after-school club. Of these, 25 take part in art, 12 of them take part in both art and music. The number of students who take part in music is X. Find the range of possible values of X. Now, this question is suggesting that a Venn diagram would be an appropriate way. So let's have a look at our Venn diagram. So what have we got? We have got art and we have got music. Now, we're told that there are 12 students who take both art and music. Okay, so 12 are taking both art and music. We're told also that there are 25 students taking art. So this must be 25 take away 12. So this is going to be, we have 13 students there taking art. Now, we've got to try and find, it says the range of possible values of X. So let me just draw another, we're going to draw the two extremes, okay, to see what are the two extreme scenarios. We know that we've got 12 there. We know that we've got 13 here. Now, in one extreme, maybe none of the remaining students, okay, maybe none of them take music. And if that's the case, if none of the remaining students take music, then what that means is that the X, what does it say? The number of students that take music is X. If that was the case, X would be 12, okay? Because none of them are taking music. And in fact, we would have 45, take away 13, take away 12. We would have 20 of them out here, okay, that are basically not doing kind of like art or music. What's the other extreme? The other extreme is that all 20 of those students are actually doing music and that nobody is not doing any of those subjects in the clubs. Okay, so that's our other extreme, in which case our X would equal 32 because it's going to be 20 add 12. So our X is equal to 32. So the range of values for X is that X is less than or equal to 32, but greater than or equal to 12. So there's our range of values that we can have for X, okay? So that is question 3, part A done. Now, what have we got next? We're 4 marks, this one. Wow, let's have a think about this. One of the 45 students is selected at random. The event A is the event that the student takes part in art. Event M is the event that the student takes part in music. Determine whether or not it is possible for the art and the music to be independent. Okay, so let's have a think about this. Now, if you may remember that if two events are independent, then what we're going to have is the probability of art times the probability of art and music, should I say, the probability of art intersection music would equal the probability of art times by the probability of music. Okay, so one way to tackle this question is let's assume that they are independent and let's see whether or not that gives us a sensible probability. So if we assume that they are independent, okay, let's see what happens. Well, what's our probability of art? We know our probability of art. We know that that is 20, those two added together. So 25 out of 45. So 25 over 45 is our probability of art. Now, our probability of music, remember it's this X, which we don't know, divided by 45, okay? X over 45. And if they were independent, that would equal the probability of art and music, which is the intersection, so 12 over 45, okay? Now we have an equation here with only one unknown. So we can basically times out all sides by 45, giving us 12 equals 25 times x. We can then divide both sides by 25. So x is equal to 12, x is equal to, let me just double check, x is going to equal 12 divided by 25. Oh gosh, let me just have a quick check about that. So x is equal to, if I times both sides by that, x is equal to 12 over 25. Okay, x is equal to 12 divided by 25. Now, let's think about this. 12 divided by 25 is equal to x is equal to 0.48. And that is not a sensible value, okay? So basically, x is equal to 0.48 there in this particular way of doing it. And because we're going to have to take that probability, our 12 over 25, and we're going to need to times that by 45, okay? So the number of students taking part in music, if this was the case, would be the probability of music, which is 12 over 45, times by all the students, which is 45. So that would give us the number of students taking music would be 21.6, okay? So we found out there that in our calculation, if they were independent, the value of x would be 12, giving us a probability of 0.48, okay? So we'd have 12 there in that one, and when we rearrange it, we'd find out we get a probability of 0.48. In fact, let me write that in a way that is clearer. So we've got there our x is equal to that, so our x is equal to 0.48, that's true. So therefore, the number of students is going to be the probability of a student taking music times by the number of students, which is 21.6. And actually, you can't have 21.6 of a student. So because this is not an integer, therefore, we can say that it's not possible for them to be independent. So they're not independent because this would be an integer value. Now that, I think, is super, super tricky. But again, in this particular way of doing it, we just assumed that they were independent, and we found out that that gave us this value of x that would make it work if that was the case. And then when we found that that was the case, that gave us 21.6 students, which didn't work. Okay, horrible that. I don't think that's very nice at all. But I hope you found that helpful, and I'll see you in the next video.